Hello students, welcome back to the next module of the chapter oscillation. Students, in the last three modules, we have already seen graphical representation of SHM for a particle starting from mean position. In this module, we'll see graphical representation of SHM but for a particle starting from extreme position. Students, as I've already told, graphical representation of SHM means plotting the graphs of x versus t, v versus t and a versus t. But in this module, we'll derive it for particle starting from extreme position. So let's start with the first step, that is deriving the expression for x, v and a. So to begin with, we know expression for displacement is x is equal to a sine omega t plus alpha. For a particle starting from extreme position, what is the value of alpha? Yes, we know alpha is equal to pi by 2 radians, and hence the expression for displacement becomes x is equal to a sine omega t plus pi by 2. Sine 90 plus theta is cos theta, and hence the expression finally becomes x is equal to a cos omega t. Moving ahead, students, let's go for velocity. We know by definition velocity is dx by dt. Let's substitute the value of x and we get it as d by dt of a cos omega t. Students, amplitude is constant for SHM and hence I can take it as constant and take it out of the differentiation process, and therefore it becomes v is equal to a d by dt of cos omega t. d by dt of cos omega t, students, is minus omega sin omega t, and hence finally I can write velocity as v is equal to minus a omega sin omega t. Let's move ahead, students. After velocity, let's derive expression for acceleration. We know by definition of acceleration, which is rate of change of velocity, it is dv by dt. Let's substitute the value of velocity and it becomes d by dt of minus a omega sin omega t. Again, minus a omega is constant and therefore I write it as minus a omega d by dt of sin omega t. Students, d by dt of sin omega t is omega cos omega t, and hence it becomes minus a omega in the brackets omega cos omega t, which finally can be written as a is equal to minus a omega square cos omega t. So we have written the expressions of displacement, velocity and acceleration in terms of time. Let's move with the next step, students. As seen in the previous modules, we'll take different values of t, and for different values of t, let's see what is the value of phase omega t. So in the expression of x, students, omega t is nothing but phase, which can be written as 2 pi by capital T into small t. Since I had already derived in the previous modules, in this module, we'll straight away substitute the values of omega t. When small t is 0, omega t overall becomes 0. For t by 4, it is pi by 2. For t by 2, it is pi. Likewise, for 3t by 4, it is 3 pi by 2. And for t, yes, it is 2 pi radians. Now, let's go with the first curve, that is graphical representation of displacement. So here is the formula of x, and let's fill up the table considering the values of x. So we have already filled up this part, students. Now let's go for the values of x. When small t is 0, we know overall omega t is also 0, and hence the expression of x becomes x is equal to a cos omega t, but omega t is 0. Cos 0 in trigonometry is 1, and hence, students, x is equal to a. Let's substitute this value in the table, and here comes a. Now, since it was detailed solved in the previous module, students, here we'll only write the values of x now. Students, when small t is t by 2, omega t is pi by 2, and let's substitute here, and cos pi by 2, students, is 0. Therefore, x takes the value now as 0. Likewise, the next value is t by 2, and the phase becomes pi. Cos of pi is minus 1, and hence a becomes minus a. For the next value, cos 3 pi by 2 students is 0 and hence the value of x is 0. Next value students is omega t is 2 pi, cos 2 pi is 1 and x again takes the value a. You can remember it directly, whether sine or cos, every alternate value you can see is 0 and if one is positive the next one is negative. Let's finally plot the graph of displacement versus time. So displacement on y-axis, time on x-axis. The peak value is plus and minus a. Let's take the values of small t. I have marked the extreme values. Let's jot down the first point students. When t is 0, displacement is plus a. So let's put it here. The next value is 0, minus a, 0, plus a. Let's join this point students. Yes, what kind of curve we'll get? You can directly predict it by the formula of x. X is equal to a. A is the peak value and the formula is cos omega t. Therefore, if I join this point, the curve will be, yes, it will be a cosine curve. So x versus t graph is a cosine curve. That's all in this module students. In the next module, we'll see the curves for velocity and acceleration.